So I wanted to sum up lessons 5 and 6 in chapter 5 because it's hard to go through the PowerPoints, and especially doing them live. I'm not sure quite what you get, and through all the inconsistencies in Zoom and internet connections. So I wanted to make sure that this was clear and that you had all of this written neatly in your notes. So we're talking about proportional relationships. Okay, and what we're going to be doing is we're going to be looking at them in tables, in graphs, and in equations. All right, to try to pull everything together here. All right, what I want you to do now is just to pause and copy down these definitions. Okay, so proportional relationship. What is that? A two-variable relationship in which there is a constant ratio between the two quantities. All right, so if you go to the store and buy one apple for 50 cents, okay, that's the cost. Every apple is 50 cents. That would be a proportional relationship, because if you kept doing, if you bought more apples, it'd be 2 apples for $1, and that would simplify down to 1 apple for 50 cents. That's what we're talking about, a proportional relationship. All right, and we'll see how those relationships can be shown in tables and their unique properties in tables, and then their unique properties in graphs, and then their unique properties in equations. Okay, now this is a good important phrase to know: constant of proportionality. All right, that's just the constant ratio, the constant ratio we talked about up here. There's a special name for it, the constant of proportionality. All right, so it's the constant ratio in a proportional relationship. All right, so let's compare and contrast proportional and non-proportional. And I've written down 2 situations here. The same company has 2 different options when you want to rent a movie. Okay, so rentamovie.com, very creative name there. They charge $3 per movie. Okay, over here though, you can also do a membership that costs $15 for the membership, but that's supposed to be a B. But the rentals are only $1 per movie now. So the rentals are less, but you have to pay a little bit up front. All right, and we'll see how this looks in a table. So let's start building our table here. Now it doesn't give me any values to choose, but I do know my 2 variables, because we're talking about 2 variable relationships here. My 2 variables are going to be the number of movies that you rent. That's what we call the independent variable. And then the total cost is going to be my dependent variable, because that depends on how many movies I buy. Okay? And what we're going to say is I'm just going to choose numbers of movies to fill in. Typically in math, you do 0, 1, 2, 3, and then you're done. Okay, but you don't have to. And sometimes you have to be flexible and think of other numbers to plug in. But if I were to buy 0 movies, this plan would cost me $0, because I haven't rented any movies yet. If I purchased or rented 1 movie, it would be $3. 2 movies, it would be $6. 3 movies, it would be $9. All right, and so on and so forth. We could do 4 and 12. All right, why is this a proportional relationship? Because when we take each of these pairs, the non-zero pairs, when we take each of those pairs and write them as ratios, all right, 3 to 1, 6 to 2, 9 to 3, and 12 to 4, they all simplify down to 3 over 1, which represents $3 per movie. Okay, so sorry I didn't show all that. I was writing, but not showing you what I was writing. Okay, so I wrote them all as ratios, all the pairs as ratios, and then they simplify down to the same unit rate. Notice, this part of the table, this one right here, is a special pair. All right, wherever you find in a table, wherever you find the 1 all right, that's going to be right next to your unit rate or your constant of proportionality 3. Okay, so this is for proportional relationships only. That value is going to basically tell you the constant of proportionality, as long as it's proportional. Okay, you can also just divide any, if you know it's proportional, you can divide any of these pairs and get the constant of proportionality. So that value, this is all your constant of proportionality. Okay, now let's check out this other situation here. It already tells you it's non-proportional, but why? All right, again, we're seeing how much it will cost to rent a certain number of movies. All right, so we're going to put in 0, 1, 2, 3, 4, so we can check it against the other table. Now, it says this time that we have a membership cost. All right, so we join before we buy any movies or rent any movies. We have to join, and we have to pay $15. So we haven't rented any movies. We have 0 movies, but what is the cost already? The cost is already $15. All right, now what's the total cost if I only rent one movie? Well, I had to pay for the rental, for the membership, and I also have to pay $1 for that movie, because that's that right there. So that's 16. All right, well, what if I buy the membership and rent 2 movies? Well, that's 15 plus the $2 for each, $1 for each movie, so that's $2, so that'd be $17. Okay, 3 movies would be the 15 for the membership, $3 for 3 movies, so that's going to be 18, and then this will be 19. Now, is that proportional? If we look at all these pairs, all right, and we write them as ratios. Oops. Do they all equal the same constant ratio or constant of proportionality? No, no, and no. All right, so why? What was the difference between the two? The original situation, what was the difference? The difference is this upfront fee of $15. Okay, it messes up the multiplier. Okay, this one has a simple multiplier, $3 per movie. It doesn't have anything else. This one has that extra fee that throws it off, so it's not proportional anymore. Okay, so proportional relationship. This is how it looks in it looks in a table. All right, and you know that this value is always going to be your constant of proportionality. You can also find that KOP, constant of proportionality, by dividing any other pair. You should get the same exact number. All right, so that's review. Now we're going to move on to proportional relationships in graphs. All right, I'm going to just see if I can zoom out just a tad for you guys. Okay, now I'm going to graph both of those recent relationships that I just talked about. So I'm going to graph the non-membership one. So it started at 0, 0, right? No money, right? When we rent 0 movies, it costs us nothing. Okay, when we rent 1 movie, it costs us $3. When we rent 2 movies, it costs us $6. 3 movies, $9. 4 movies, I'm trying to line it up as nice as I can. Okay, $12. What do you notice about this? What do you notice about these dots? I notice that they're a straight line, fairly straight. I mean, I was as accurate as I could on a piece of non-graph paper. All right, straight line here. We got that straight line. Should have brought a ruler. All right, a straight line. Now, let's compare that to the other situation where you had to pay the $15 upfront fee. So even at 0 movies rented, it was already going to cost you $15. All right? And then if you did go and rent 1 movie, you'd already paid the $15 plus $1, so that would make it $16. Then 2 movies would be $17, 3 movies would be $18, 4 movies would be $19. Okay, now, what do you notice about that? Okay, I notice that it's also going to be a straight line. But there's one significant difference. Significant difference is where they start, all right, or where they cross the y-axis. Okay, this one starts at the origin. This one starts up at 15. So, all proportional relationships, when you graph them, are going to be straight lines through the origin. All right, that is our key for proportional relationships in graphs. Okay, proportional relationships are always straight lines through the origin. Okay, whereas if you have a line but it doesn't go through the origin, okay, it's non-proportional. It's a non-proportional linear relationship. These are both linear, but only one of them is proportional, and that's this one because it goes through the origin. Now also, I can demonstrate kind of a connection between the table and the graph. Anytime I pull a point, all right, that is 1, 3, 2, 6, 3, 9, and 4, 12. If I make those into ratios, all right, I get those values that I had before, 6 over 2, 9 over 3, and 12 over 4. They are all equal to that 3, which is our constant of proportionality. Okay, so trying to tie it all together, so you can kind of see the table right in these 4 points, and obviously you have the 0, 0 right there. All right, so connecting it all. So the key, proportional relationships are always the straight line through the origin. Also, another key is that this point, right above 1, tells you the constant of proportionality right there. Okay, so that's our constant of proportionality as well. Okay, so if it's proportional, then whatever it is, 1 comma whatever that value is your constant of proportionality. Now you can get it other ways, like just dividing other pairs and getting that constant of proportionality, but that can be useful at times too. Okay, last thing is proportional relationships in equations. Okay, you can always write an equation for a proportional relationship in this format: y equals kx. All right, where k represents that constant of proportionality. All right, and we know how to find that constant of proportionality. We know that we just divide the pairs of values in a table, or divide the pairs of values in a graph, whatever the coordinates are, or we can just find 1 comma whatever, and that will be our constant of proportionality. Depends on whichever method will be the most accurate for the situation you've been given. All right, so all you have to do is find the constant of proportionality and plug it in. So let's think about the situations we've talked about so far. The $3 per movie rental. All right, where y would represent the total cost, right? Total cost. X represents number of movies rented. So how are those related? How are those related? Well, they're related by that constant of proportionality. If I take, right, the 3, our constant of proportionality up here, if I take that and I multiply that by the number of movies that you rented, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, right? The x value times 3 always gives you the y value. So we can write that in our equation here. We represent, right, that's the total cost, always equals 3 times, or $3, for every movie. Okay, the X represents the number of movies, the Y represents the total cost, the 3 tells you what you have to multiply by the movies to get your total cost. All right, so that is your equation for this particular situation. Now the other situation, this is just bonus, all right, is going to be a little bit different. Okay, it's actually, you still have that rate of 1x, except there's going to be a plus 15 in there because of that initial upfront fee, right? We have to pay the 15 plus the $1 per movie, all right? But this is coming up later in the year, so you really don't have to know that yet. What we're focused on is here, okay? An equation for a proportional relationship. Very simple. Find the constant of proportionality, plug it in. Cool. Hopefully that ties things together. Good luck with the lesson today.